Well, this video is for Trigonometry, Math 112, Section 2.1, beginning of Chapter 2. So in Chapter 2, what we're going to be looking at is what's called the unit circle concept of trigonometry. So we've been studying trigonometry in a right triangle. Now we're going to study how to use angles and lengths in the coordinate axes. So we look at our x and y axes, the Cartesian plane, and let's say we take a radius of 1 and we rotate it away from the positive x-axis. So it starts down here and it kind of rotates in this direction. This is our angle theta. We drop a perpendicular to the x-axis, and now we have a right triangle. Okay? This point has coordinates x and y. This is x, this is y. Now, notice in this situation, we can say that the sine of theta here is y over 1, and the cosine of theta is equal to x over 1. So this point right here represents the cosine of theta for the x-coordinate and the sine of theta for the y-coordinate. Okay? Now, what that does for us is that allows us to go past 90 degrees, right? I don't know if you remember, but in Chapter 1 I mentioned a couple times that in a right triangle, neither one of these angles can be more than 90 degrees. Okay? They both have to be less than 90 because they live in a triangle that already has a 90-degree angle. Now, if we move to this conceptualization of an angle and trigonometric functions of that angle, now we can generate sines and cosines for angles 90 degrees and more. Okay? So let's look at how that happens. Let's see here. I'll leave this up here for a minute, and then over here, draw another one. So here is where theta is 0 degrees. Okay, there's no rotation at all. This is the point 1, 0. That says that the cosine of 0 is 1, and the sine of 0 degrees is 0. Okay? Now, if we rotate 90 degrees in this direction, this is the point 0, 1. That says that the cosine of 90 is 0, and the sine of 90 degrees is equal to 1. And then I'll finish this off by going over to 180 degrees. This is the point negative 1, 0. So cosine of 180 degrees is negative 1, and the sine of 180 degrees is 0. And then down here, all right, this distance is also negative 1. This is the point 0, negative 1. So cosine 270 is 0, and the sine of 270 is equal to negative 1. Now you can get these values. You can get these values on your calculator, but this is where they're coming from. Okay. All right. So let's see here. Let's look at something else here. Right. So now, this was all about what happens if you're on one of these axes exactly. 0, 90, 90, 180, 270, and so on. Okay, all those multiples of 90 are going to generate values for the sines and cosines of either 0 or positive or negative 1. All right. What if we're not on those axes, but we're not in the first quadrant anymore? Let's see here. Okay. What we can do then, let's see, let's go over here. 140 degrees. Okay, so clearly this angle can't be in a right triangle. Right? So it would be difficult to generate values for the sine and cosine of this angle based on a right triangle. So what we do is we create what's called a reference angle. So this is still the point xy. It's still going to represent the cosine of 140 and the sine of 140. This length is still 1. Okay? This is a right triangle. It's perpendicular to the x-axis. This angle in here is what's called the supplement of 140 degrees, which is 40 degrees, right? Because the full rotation there would be 180. Okay. So what we can do here is we can generate values. Let's see here. Now, I don't have lengths for these. Okay. What can I do? Well, I can work off the values for 40 degrees. So, if we know that x coordinate is the cosine of 140, it's also in this right triangle. If we just take a right triangle like this, where this is 40 degrees and this hypotenuse is 1, then let's say I call this A and I call this B, then the sine of 40 is A over 1 and the cosine of 40 is B over 1. Alright, so let's see what those values are here. Alright, so sine of 40 degrees, make sure I'm in degrees, yeah, about 0.640, well, let's call 6428. Alright, and then the cosine, oh, and these are approximate, there we go. Cosine of 40, 0.7660. Okay, so now we know the distances for A and B. If we come back to our coordinate axis over here, that y coordinate is going to be 0.6428. The x coordinate, the distance here is going to be 0.766, but the x coordinate itself is going to be negative 0.766, because over here the x's are negative, right? Over here the x's are positive. So what happens in this scenario is that the x coordinate, the cosine of 140, is negative 0.766, and the sine of 140 is the y coordinate, which is positive 0.6428. Right? So that's one of the fundamental ideas for this unit circle trigonometry, is that once you move out of the first quadrant, the sines and cosines can be positive or negative, depending on the values of x and y. Okay, so let's dig into that a little bit more deeply. So that's in the second quadrant. So the sides of this triangle can sometimes be negative depending on the values of x and y. Here, y is positive, so the sine is positive. Over here, the x is negative, so the cosine is negative. And if you look at the tangent, the opposite over adjacent, that will also be negative. All right? So, I'm going to start working on a diagram here. In the first quadrant, all of the trigonometric functions are positive. Okay? In the second quadrant, the sine is positive. Okay? Notice the cosine and the tangent were both negative. Now, down in the third quadrant, let's see what happens down here. We rotate an angle all the way around, something like, let's say, 215 degrees. Okay, so it's more than 180, but it's less than 270. So, to work with this in a triangle, drop a perpendicular to the x-axis, and then we get our reference angle in here, which, if this is 215, this reference angle will be 45 degrees, because it's 45 degrees more than 180. Okay? Now, the y is negative. The x is also negative, and so as a result of that, both the sine and cosine will be negative, okay? But the tangent, which is the opposite over the adjacent, is a negative over a negative, and that makes the tangent positive, okay? Let's see, we'll say x greater than 0, y greater than 0. Here, x is less than 0, y is greater than 0. Here, they're both negative. And then in the fourth quadrant, let's see what happens here. We rotate all the way around. We'll call this, let's say, 315 degrees. Drop a perpendicular to the x-axis. The x is positive here, but the y is negative. And the hypotenuse in this unit circle trigonometry is defined as being 1. Okay? Let's see here. So, in the fourth quadrant, with the x positive and the y negative, if the x is positive, then the cosine will be positive. Okay? But the y is negative, so therefore the sine will be negative. And the tangent is going to be a negative over a positive, which is negative. So you can see this diagram defines which of the trigonometric functions are positive, and then by default, which are negative. Here in the fourth quadrant, x is greater than 0, y is less than 0. So this is a very fundamental idea for working with unit circle trigonometry. Okay? Is which quadrant your angle is in, and therefore which of the trigonometric functions are positive and which are negative. Now, like I said, you can type into your calculator, sine or cosine of 315 degrees, and it'll return the correct value with the correct positive or negative sign. All right? But it's also good to understand where that's coming from. All right? Let's see here. Let's see what else we need to talk about. Reference angles. Okay. And then I think the last thing I want to talk about before we get into the problems is to look at negative value angles. All right, make sure I didn't push the whiteboard out of the screen here. Okay. You're still in good shape. Okay, so if we have a negative angle, so positive angles rotate in a counterclockwise direction. Right? And I'll put the edge of the angle there. Now, negative value angles, theta less than 0, are going to rotate in the opposite direction. Okay? They will still have a reference angle that gets created when you drop your perpendicular to the x-axis. Then you'll have this little reference angle in here that can give you information about the trigonometric ratios for this angle, whatever that angle happens to be. And then you kind of just have to adjust your positive and negative signs based on this information right here. Okay, so that's the basic ideas for section 2.1. Let's start in with the exercises and see what they look like. All of this, of course, is in the textbook in section 2.1. I'll leave this up for a minute. If I need the space, I may end up erasing it. But let's start working through these exercises. Okay. So, in this first section, we've got information about the sines and cosines, and then we want to determine which quadrant that's going to match up to. So I'm glad I left that up there. Let's look at problem 2 here. We've got the sine of theta being negative, and the cosine of theta being positive. All right, well, let's see. The sine of theta is going to be negative in quadrants 3 and 4, but with the cosine being positive, that says this must be quadrant 4. Okay. Problem 4. Cotangent greater than 0 and cosine less than 0. Now, so this is one of the first times we've run into one of these reciprocal functions. These are given on page 55, right above the exercises. I'll write them down over here. Cotangent is the reciprocal of the tangent, and so it's going to have the same sign. If the tangent's positive, the cotangent will be positive, and vice versa. Okay? And then we've also got the secant, which is 1 over the cosine, and then the cosecant, which is 1 over the sine. So, the only thing that we really need to know at this point, later on we'll do more with these functions, okay? But for right now, all we need to know is that these have, if this one's positive, and vice versa, okay? So if the cotangent is positive, that says the tangent is positive as well. That means we must be in either the first or third quadrant, right? The tangent's going to be positive here, where they all are, or in the third quadrant where x and y are both negative. That makes the tangent positive. Okay, but the cosine is negative. That means we can't be in quadrant 1, and we must be in quadrant 3. Okay. Problem 6. Sine is positive, and cotangent is also positive. Okay. Well, if the sine is positive, we must be in the first or second. But if the cotangent is also positive, that means we must be in the first quadrant. Let's see, one more here in this section. Cosecant positive, and cotangent negative. Okay. So what we're saying with the cosecant, that means the sine is positive, so it's either first or second quadrant. If the cotangent, and consequently the tangent, is negative, that means it can't be the first quadrant, and it must be the second quadrant, where the only thing that's positive is the sine and the cosecant. Okay, so that's that first section, just kind of getting used to this definition right here, and also working a little bit with these reciprocal functions. We'll do, like I said, we'll do more with them later on in the course. Okay, let's make some space again. Okay. So, in this next set of problems, 9 through 23, we're looking for which quadrant does the angle terminate in, and then we want to find a reference angle for it as well. So, problem 10, we're looking at positive 330 degrees, so you're going to go all the way around almost to 360, all right? But we're going to stop before we get there. stop at 330 degrees. So there's 330 degrees. The terminal side is in the fourth quadrant. So that's the first question there. We don't actually want to draw that Roman numeral over the Q as well. There we go. All right. So quadrant 4 is where the terminal side of that angle is. What's the reference angle? Well, what's left inside here? Okay, all the way around is 360. We went 330, so that means our reference angle must be 30 degrees. Okay, and there's the perpendicular that we drop to the x-axis to find that reference angle in there. Okay, let's keep going with these. Let's see here. Let's do problem 14. And this one, it's a 300-degree angle, so once again, we're in the fourth quadrant. Okay? Drop a perpendicular to the x-axis. There's our reference angle in there. And what is that going to be? Again, all the way around is 360. We went 300. That says that our reference angle here is going to be 60 degrees, which means that the absolute values for sine, cosine, and tangent for both of these angles will be the same, but they'll differ in whether they're positive or negative. Okay? And this chapter is leading into making graphs of sine and cosine functions, so we'll work our way up to that as we work through the chapter. So this is first defining how do we find sine, cosine, and tangent for angles that don't fit into a right triangle. And so that's what this process is all about. Let's see here, problem 16, 225 degrees. So again, it's helpful to know the values of these quadrantal angles, which are multiples of 90, okay? It's also helpful to know them in radians. This one's pi over 2, this one's pi, this one's 3 pi over 2, and when we get to 360, this is 0 radians, but when we get to 360, that's 2 pi radians. Okay. Let's see here, problem 16, 225 degrees, so that's going to be right in here. Right like that. So if this is 225, then let's see here. Yeah, 225. Then that says our reference angle here is we subtract the 180 from the 225 to get this leftover portion here, and we find that that alpha there is going to be 45 degrees, because 45 plus the 180 makes the 225. And this terminates in quadrant 3. So, terminal side is in the third quadrant, and the reference angle in here is 45 degrees. Okay. Let's see here. Problem 20. 7 pi over 3. Well, let's see here. Theta is 7 pi over 3. So there are a lot of different ways to approach this problem and how to think about it. Okay? Tell you something that I noticed right away here is that this is more than 2 pi. That means we've gone all the way around once. Okay? You can also turn this, you can just turn this into degrees if you want to. Alright, and you can find out how much that is. I'm guessing it's going to be 400 something. Well, let's see. Pi over 3 is 60. Yeah, and so 7 times 60 would be 420 degrees. Alright, so that's going to take us all the way around. There's the 2 pi radians, and then just a pi over 3 past that, right? Because this is 2 pi plus pi over 3, okay? This is 6 pi over 3 plus 1 pi over 3 makes 7 pi over 3. So there's our terminal side of the angle in the first quadrant. So there's the answer to that question, quadrant 1. Drop a perpendicular to the x-axis, and then there's our reference angle right there, alpha, which is how far past 360 or 2 pi did we go? Well, when I split this up, we went past it pi over 3 radians, so that's going to be our reference angle. Okay? And so if the angle is given in radians, then it's good to keep the reference angle in the same units. Alrighty. Okay, let's see what else we've got here. I definitely want to look at least one more of these. Yeah, we'll do problem, 22. One more of these radian problems. Now this one, problem 22, is actually very similar to problem 20. So problem 22, we're working with 7 pi over 6. Okay? And I say that it's very similar because this one was 1 pi over 3 more than 2 pi. This one's going to be 1 pi over 6 more than pi. Right? Because 6 pi over 6 is just plain old pi, and then 1 more pi over 6 would make 7 pi over 6. So what I'm saying here is that pi radians is this 180 degrees. There's pi radians, and then we go past it, pi over 6, and then that's going to be our reference angle, pi over 6, with the terminal side in quadrant 3. Okay, so that's that section there. That second section on page 55 is all about where does the angle terminate, what quadrant are you in, and then what's the reference angle, so that'll give us information about the sine, cosine, and tangent for those angles. All right, let's see here. Got one more set of problems to look at in this section. Let's make some space. So in this third section of 2.1, we're going to be given some information. Let's see here, I'll start with problem 24. That tells us the sine of theta is negative 12 over 13, and we know we're in quadrant 4. Okay. So let's go into quadrant 4. And there's our angle. There's our triangle where the reference angle is. So if the sine is ratio of negative 12 over 13, this hypotenuse is typically a positive number, at least in this textbook, and for all the things that we're going to be doing, we're going to have a positive value on the hypotenuse. If you do a negative value on the hypotenuse, it goes off in the other direction, but that's actually a direction that we're not going to go in. Okay? So the 13 is always positive. The negative 12, which represents the side opposite, will take the negative sign because, right, the y-coordinate here, which is what this line represents, it represents the y-coordinate. The y-coordinates down here are negative, right? Up here they're positive, and so forth. So over here, the x-coordinate is positive, and we need to find out what that is. So what we'll say is x squared plus negative 12 squared equals 13 squared. Now, if you're familiar with this already, this is one of those, what's called a Pythagorean triple, okay? Where these are all going to be whole numbers. The x is going to turn out to be 5. So x squared plus 144 is 169. Subtract the 144 on both sides. X squared is 25. And so x turns out to be 5. All right. So x is 5 here. And what do we need to do? Okay. We already know the sign. Now we can say that the cosine of theta, let's see here. Well, yeah, we can base this off of our reference angle in there. The cosine of that angle is going to be 5 over 13, and it's going to be positive because both x and the hypotenuse are positive. Okay? The tangent is going to be negative 12 over 5. The opposite over the adjacent. The 12 will keep its negative sign. The 5 is a positive number. Tangent's negative. Cosine's positive. Sine is negative. Okay. So there's problem 24. So the reason why, one of the reasons why I put these problems in here is because it kind of puts all of these ideas together. You get the Pythagorean theorem, you get this concept here for which of the trigonometric functions are positive and which are negative. You're working with the right triangle, but the angle itself is actually this angle that's more than 300 degrees. There's a lot going on here. Okay? All right. Well, there's problem 24. Let's look at a couple more of these. Good. All right, so problem 28. This says tangent theta is negative 4 over 5, and we're in the second quadrant. Okay. Draw a little diagram. Here's the second quadrant. There's our terminal side for the angle. Drop the perpendicular down here, and there's our reference angle. And we're saying that the tangent, which is the opposite over the adjacent, is going to be negative 4 over 5. Now the y in this case is positive. Okay, so this opposite side, even though the negative sign is in front of that 4, that's going to be a positive 4. It's the x-coordinate, right, that is going to be negative, and over here, that's going to be negative 5. So there's the starting point for the problem, is to get set up in the quadrant that we're identified as being in, and then label the sides of this triangle based on the value of the tangent, but keep the appropriate positive or negative sign with each side of the triangle. Okay, now that we've done that, let's find C. All right, let's find the hypotenuse. 4 squared, negative 5 squared is going to be C squared. 16 and 25 is C squared. So that should be 41. C is going to be the square root of 41, and it'll be positive. Okay, so let's see. We know the tangent. So the sine of theta then is going to be the opposite over the hypotenuse. 4 over square root 41. And the cosine of theta is going to be the adjacent side, negative 5, over the hypotenuse, square root 41. So there we go. Sine, cosine, and tangent. And that's all we're looking for in these problems. And we're always given one of them. All right. Let's look at a couple more. -2, and that the tangent is less than 0. Okay? Well, let's see here. Remember, the secant is the reciprocal of the cosine, which for one thing says that the cosine is also negative. So the only place where that happens is in the second quadrant. Okay? Because the tangent is positive here and here, cosine is positive here and here. The only place where they're both negative is in quadrant number 2. Okay? So, if the secant is -2, that means the cosine is -1/2. Because they're reciprocals. Alright, so now we've got all that information. Let's make a little diagram. Draw our angle going over here into the second quadrant. Drop the perpendicular. There's our reference angle. Now, we know that the cosine, which is the adjacent side over the hypotenuse, is -1/2. So we'll make that side -1 and that side +2. Alright. Then we can find the missing side using the Pythagorean theorem. -1 squared, I'll call this y, plus y squared equals 2 squared. So, y squared is 3, and y is the square root of 3. Okay, so let's see here. We've got the cosine, -1/2. That means that the sine of theta is going to be square root 3/2. And it's positive. That's what we were saying before. In the second quadrant, the sine function is positive. All right? What else we need? Tangent is going to be negative, and that's going to be square root 3/-1. You can leave it like that if you want to, or we can call it negative square root 3. All right. 32 is a little bit different, a little bit trickier. We've got these reciprocal functions in there, and we had to deduce which quadrant we were in. The problem didn't tell us. All right, let's see. Let's do one more of these, or maybe 2 more. Let's see how it goes. Make some space. Problem 36. We've got cosine equal to -2/5, and the tangent positive. Okay. Well, with the tangent being positive, that says you're either in the first or third quadrants. With the cosine being negative, we must be in quadrant 3. And the problem doesn't ask us about that, but it is helpful to know that. Okay? So, there's our angle theta, there's our reference angle alpha, and there's the triangle that alpha lives in. Okay? Let's see, the cosine, which is the side adjacent over the hypotenuse, is -2/5. So this side is -2, the hypotenuse is +5. We'll find this y value, which will also be negative, by using the Pythagorean theorem. So we'll say y squared -2 squared equals 5 squared. So y squared is 21, and y is the square root of 21. Here we can consider both the positive and negative square roots, because in this case, the y, as it turns out, should be a negative value, negative square root 21. Okay. Now that we've got that set up, let's see. We've got the cosine, -2/5. the sine should be negative square root 21 over 5. And the tangent is going to be square root 21 over 2. I could put the negative signs in both of them. It's actually negative square root 21 over negative 2. But those two negatives would cancel and give us a positive answer. So there's no reason to keep those two negatives in there. All right. Well, I think that's a good place to stop for section 2.1. We will pick back up with these ideas in section 2.2. As always, if you have any questions, please let me know. Thanks.